Hey guys, welcome back to the coding interview pattern series. This is the sixth video. In this video, we are going to cover the top k elements pattern. So as name suggests, it's something related to finding the top k elements, top k numbers. It can be top k largest number, top k smallest number, top k less frequent repeated, more frequent repeated numbers, kind of things. Correct. Now, in this one, it's nothing much theoretically. Better we can go by the example. So what it says, that suppose you want to find the top k largest number from the list of numbers, how you can do it. Before I start, one request is there. In this top k elements pattern, we are going to use the minimum heap and maximum heap. So if you have not watched the two heaps pattern video, please watch it. It will be easy for you to understand heap, minimum heap, maximum, and then come back. So let's dive it. So what say? Let's say we want to find the top k largest number, or let's say we want to find top k smallest number. Okay, just keep in mind that when we want to use the find largest number, we will use the minimum heap, and when we find the smallest number, we will use the maximum heap. Okay, if this is not clear, why using minimum heap for largest and why for maximum for smallest, forget about this one. Let's understand the concept. So what we are saying is, let's say we have 5 numbers, and we want to find top 2 largest number. So out of 5, we want to find the top 2 largest number. Now forget minimum heap, maximum heap. What we will do is that we want to find the top 2 largest number. So let's say our number is A, B, C, D, E, F. Don't confuse. This is not number, this is ABCD, but I have not kept the number. If I keep the number, it may create confusion why I am comparing it. It may say this is small, less. So assume this is just number. Now if you have the ABCD number, you don't have comparison who is large and who is small. So for that purpose, to avoid the comparison while we are discussing the concept, I kept ABCD, EF. So if this is the clear, what we are going to do is, we'll take the first 3 number as it is. So what we are saying, okay, you 3 number, come and sit here. Okay, so let me fit this number A, B and C. I want to find, sorry guys, I will take the top 2 number because I want to find the top 2 number only. So I will take the first 2 number. So the first 2 number I am saying, okay, come and sit in this area. Okay, and assume this is my result area. Now other remaining, this one, you sit here. Now in this one, let me put in a different way. I am putting that, okay, A and B, I am putting, so you are sitting here, and these 4 are here. Now obviously I have to compare, I have to check from this number also if someone is larger than these 2. Correct. Now if suppose I am taking this C number now, because I decided 2 number, I have to compare it. Now if I take the C number, I have to compare with A and B both, let's say, and I have to kick out the small number. Suppose C is greater than both A and B, I have to kick out one number, because I need to keep the place for this C number. And in this case, obviously I will kick out the smallest number, because we want the largest number. So large number I will keep for next comparison. So I will keep the small number. Now if I want to keep the small number, what I think is, instead of comparing, suppose now I have 2 numbers. If I have 100 number, I have to compare with all 100 numbers, right? That A, if C is bigger than any of the number, right? I have to compare like that. What I can do is, I can tell these 2 numbers who are sitting here that, hey, please sit in the descending order, or in the way that the smallest number should be on the front. Though the smallest number should be here, and then all the larger number come like that. The smallest number always sit on the front, so whenever the new number come, it will compare with the front number. If it is more than that one, keep that front number out and take your place. So in this way, if it is not greater than the front number, we are sure that all other numbers are more than this number, so he will not able to beat any number. So our comparison is less. Second thing is, it's easy to kick out the same number, the front number. So we will kick out the front number. Same thing, once this number entered here, suppose C was greater than B, C came here. Then we will say again, okay, arrange yourself. Who is the smaller? If C is smaller, let it be there. Suppose no, C is bigger, A is smaller. Then we say, okay, when C go here, A sit here. Now A become front. Now again the next number will come. It will compare with A. If it is bigger than this one, it will kick out the B, and D will take the place in this one, and they will rearrange their location, and the smallest number will come on the front. And after displaying all the things, here 2 number will left, and this 2 number will be the largest number because we kicked out all the smallest number. And whatever we did here is nothing but we used the minimum heap. How? Let's understand a little bit more. Okay, so now we will go with the some number example. So it will be easy for us to understand. Before I proceed, just keep in mind that this top k elements, and we are using minimum maximum, we use for the unsorted arrays. Or if it is sorted array, it's easy to find it, right? But if it's unsorted array, and if suppose we said, okay, we have this number and we want to find the top k largest number, what you will do? First you will sort the array. If you sort the array, it will take big of n log n, and then you will iterate for the k, so it will take the big of k. But using the top k elements, what we can achieve this on the big of n log k, because our sorting will happen for the k number only, k numbers only, not for log n. In worst case, it can go big of n, because if the n is equal to k. So let's understand how we are going to do it. Let's say we have this array, number 2, 5, 3, 6, 9, 15, 11. 1, 2, 3, 4, 5, 6, 7 number is there, and we said k is equal to 3. Find the k largest number. Find top k largest number. Top k largest number, that is the problem statement. Now we said the largest number, we will use the minimum heap. We little bit explained what is the minimum heap. Let's now start using it. So minimum heap, what it do is, it keeps smallest number always on the top. So we need to find top 3 largest number. So we'll take first 3 number and we'll create the minimum heap first without comparing anything. So if we create the minimum heap, first we'll put the 2. So I am putting the 2. Okay, 2 is done. 5 is greater than 2, so it will go down. So I am putting 5 here. 3, again comparing with the root 2, is greater than 2, so I am putting here 3. So this is the minimum heap, because if you see the root level, it is minimum number. And if I remove this 2, I just need to exchange 3 here, again 3 will become minimum number. So I have this minimum heap ready. Once we have the minimum heap ready, we'll iterate through all the rest of the numbers. So let's start with the 6. Now when we insert the 6, we'll compare with the top number, because we know this is the minimum number. If 6 is greater than this 2, we'll say okay, kick out this current number and insert the 6 inside. So let's say first let's do this step by step. We say okay, kick out the 2 number. Okay, 2 is gone. 6 came and seated here. But now this is violating the minimum heap property, because minimum heap need to have the smallest number on the top. So we need to rearrange it a bit. So if you rearrange, the 3 will come on the top and 6 can go here. So 3 will come here and 6 can here. Step is done. So what we need to do is, we need to see if new number is greater than the root number, then replace it with new number, and then just rearrange number. See, in coding, this step will be not needed. Why? Because we will be using the queue or heap where it will be auto sorted. We already told that queue that hey, whenever the new number comes, you just auto sort it. So this will be not needed, but theoretically we need this one. So we see in the we will do the coding. We just insert the 6. It will rearrange. It will make sure that 3 is on the top, because 2 is sorted. If it is clear, then let's move at the new number. So we are getting 6. 6 is greater than 3. Okay, so we'll put the 6 here. Oh, sorry, not 6, 9. 9 is greater than 3. We'll put 9. But again, it's violating the. So I am replacing 9 and the 5. Because the 5 is the smallest number now. So I am putting the 9 here and 5 here. Correct? Going at 15. 15 is greater than 5. So I am putting the 15 here. So become 15. But 15 again, I need to rearrange. So it is auto sorted. I will replace with the 6 and 15. So 15 will come here and 6 will come here. I am going one step ahead. 11. 11 is greater than 6. So that means I need to kick out the 6 also. I put 11 here. But again it's violating. So I am keeping the 9 top and 11 here. So I am keeping the 9 here and 11 here. There is no number. That means this 9, 11 and 15 are top 3 largest number. If you see it, 9, 15, 11 are top largest number. If accidentally I put this number last, even if you put anywhere, it doesn't matter. Okay, so don't consider like that this was last number so it came it. It's not like that. It's based on this minimum heap property. Clear that, right? So yeah, so it's something. If you want to have the smallest number, we will use the maximum heap. So maximum, what will happen? It will have the maximum number on top. We'll keep replacing with the reverse order. We'll see if this new number is smaller than this one. Then keep inserting it. So at the end, we will have the smallest number. Correct? So fine guys, let's move. Take one more problem. For this, we will do coding also after explaining on the whiteboard. So moving to the next problem. One thing I want to tell you in the last problem is that we find the top k largest number is. It was the largest number as per the sorted sequence. It's not distinct number. So what I mean is, let's say the sorted number is like that 1, 2, 3, 4, 4, 5. Okay. And if asked to find the top 2 largest number, then, or if suppose like this, okay, and top 2 largest number, then it should be 2. If top 3, it should be 3 like that. So it's not distinct number. It is as per the sorted order. Okay, this is the clear. Let's go to take one more problem. Now we need to find the top k frequent number. Frequent number. So it means top k most repeated number. So in the array there are some duplicate numbers are there. we need to find which numbers are repeated more time, whose the frequency is more. So let's say we take some array 1, 2, 2, 3. Oh, it's not sorted, it's just anything. Okay, 4, 6, 7, 8, 8, 8. Oh, maybe not. It doesn't matter. I'm just taking random number 11. Okay, I think it took lots of number. It's fine. It will take some time, but we'll solve it. So what we need to find it? We need to find it. This is our input number, and we want to find the top. Let's say we take the k equal to 4. So we will take the top 4 more frequent number. I hope it is 1, 2, 3, 4, 5, 6, 7, 8. Oh, they have the more number, so we find the top k 4 number. So maybe naive approach, what we'll do is we'll take the hash map, we'll keep the frequency of each number, and then we'll iterate through the hash map and we'll get the top k frequent number. But in this case, time complexity will go big of n k. So we'll use the hash map in our solution also, but after that we will use this top k elements which we use the minimum maximum heap, and in that way we'll be able to use or get the log of big of n log k time complexity. Let's see how we can use it. So first we will prepare the hash map. That we need the what is the frequency of each number. So let's prepare here. Let's find the unique number. We have the 1, then 2, 3, 4. I'm just putting in sequence, doesn't matter. 6. So don't confuse it, it's not sorted. So let me take that as per sequence. Okay. So 1, 2, 3. Then I have the 6. Then I have 4. Then I have 7. Then I have 8, 9, and 11. 1 frequency is 1. 2 is 2 time. 3 is 1 time, 6 is 2 time, 4 is 1 time, 6 already covered, 7 1 time, 8 2 time, 9 1 time, 11 1 time. So as per this, this should be our result, right? No, oh, this one and 1 can come anyone. Okay, because these two are the frequent number, 3 and 1 can any number. Okay. So let's see how we can solve it. So we have this ready. This has not, we need to prepare it. After preparing this one, we need the top frequent. It's kind of largest. Top frequent means large, right? So we will use the minimum heap. Now we will prepare the minimum heap for this one. So what we will do is, when we say this 1, this is frequency, this is the actual number. But we want the top frequency, that means we want based on the frequency. So over the minimum heap, the sorting will be based on the frequency. Now with the frequency, we need to keep corresponding link of the actual value also, because at the end we need to derive the value, is not frequency. So our heap will be, when we do coding, we can take the integer array, like first index is suppose frequency, second index is the actual value. So like that we can do in coding, but here we will take kind of the two values. So we will start inserting first. Minimum heap, we will insert 0 first, 1 and 1. Please note that the first, okay, let me put the same color I am putting here, so it will be easy for us to understand. So it is 1 and the 1. Comparison will happen based on this one. Okay, so this is the first I put it. Second I have 2 and 2. So 2 and 2, 2 is greater than this one, so I put the 2 here. This is a little bit confusing. Let me try to put it 2 and the frequency is 2. Okay. Okay, this is minimum heap. Minimum is on the top 1, so that is fine. So I have done this one also. We have done this one also. We are putting 1 and 3. Again, one number is less than or equal to this one, so we can put here 1 and the 3. It is again minimum heap, so no issue. Now 2 and 6. This 2 I can put here. correct. See, minimum, it's again the minimum is the top number, then this is also same, so it's fine. So it's again property placement there. Now see, when we keep putting this number, we need to make sure that the size of heap shouldn't go more than this 4k. So up to now it's 4 is there, so we have not done anything. So this is fine. But we need to keep checking on each adding the value each time. So now we add the 4, which is 1 and 4. So if we add the here, suppose I am adding the 1 and 4, 1 and the 4. So first we need to compare it. If this is greater than this or not, greater than or equal to or not, correct. Now this is not greater than or equal to, I don't need to insert also. So I can remove it, let it be there, I don't need to insert it. Because this is same, see we want greater than number only. So this is done. Now we have 7 and 1. This 1 is not greater than or equal to, I can skip that also, the size remains same. This check this 2 and 8. This 2 is greater than this one, so I can eliminate this one. I have to kick out this one and I have to insert the new number, which is 2 and the number is 8. Now it is violating this one because I have to rearrange this one. I have to maintain this is the minimum heap. So to maintain this one, I can exchange it to and it will be fine. So this was, just remember 1 and 3 and 2 8. So I'm putting 1 and 3 here, 1 and 3 here, and I'm putting 2 8 here. So 2 and the 8. So this is done. Now I have 9 and 1. 1 is less than or equal to, it's not greater than 9, right? It's not greater than this one, I can skip this one. 1 again, it's not greater, I can skip this one. So in this one, this is our top frequent number. If I give the result, it is 3, it is 2, it is 6, it is 8. 2, 3 to 6, order doesn't matter. If it is asked you to return in some sequence, you can take this value and sort according to the requirement. Let's say ask that return in the sorted order, you can take this value. Now what was your expectation? 2 was there, 6 was there, 8 was there. So 2, 6 and 8. 2, 6, 8 is there, and 3, as I said that one can any with this, maybe first value can be it can be any number. Right? So that 3, 2, 6, 8, this is our result. These are the top frequent number. If it is asked about less frequent number, you can use the maximum heap and return the same number kind of things. So just clear, we need to prepare the hash map. After preparing hash map, we need to create the minimum heap, and minimum heap value or sorting should be based on the frequency, but we need to keep track of the actual number also, so that finally we need to return the actual number. In coding, the method will be like maintaining the array or something. We'll see at the coding time, but just remember the concept part. So if this is the clear, let's move on in the Eclipse and try to implement this in the programming language.
Hey guys, we are back to Eclipse. So let's create one class for this new pattern. This is top k elements, and we want to find the top frequent elements, right? Okay, let me create the main method. We're not going to use now. Okay, so now in our method, what we said is we will get the list of numbers. It can be array or list, and we'll get one k number. From there, we need to find top k frequent numbers, and we need to return the list of numbers or array numbers. So let me create this one method which will return the integer array and find top k frequent numbers. Okay, what will get input? Will get input as the it can be it can be array, it can be list, anything. You just need to handle it. I'm just giving the array. What we need to return it? Here we said we return the integer. But see, the issue with integer is we don't know the size, how many frequent will be. So we have the top k, right? Okay, we can define the size. Sorry. So integer result is equal to new integer, and we can know the top frequent k number. So we can define the size, and we can return result. Second, I think I defined the integer, but list would be easy for us because in the integer array we need to maintain the index that hey, insert at this index, this index. So better we return the list. That would be better option for us. So I'm just changing with the list. Okay. So reason is I don't need to see when I'm inserting the number. I don't need to maintain the index. I can just simply keep adding this one. Okay. So that is the result. I changed to the list. New array list. Cool. Okay, and we result this one. Okay, fine. Now as we said, what we do, see, first we, as we said, we need to have the hash map to have the frequency for each number. So we'll define the hash map first. On the map side, what we will have? Map side, we need to have the first is integer number, and the frequency also will be in the integer. So this will be like number frequency, and we'll take the hash map. Okay, now once we have this one, what we'll do, we'll just iterate through its numbers, and we will insert these numbers and frequency in the map. So let's insert iterate through this one, integer number, and just okay, cool. Now we'll insert the frequency in the map. So map we will say okay. See, when we are putting this in map, we need to see, we can just check the first the frequency at this one. Instead of that, what we can do, we'll take okay, what is the frequency of the current one, if the entry is there or not. If entry is there, then add +1. If not there, add, oh, means entry is there, just add the plus. If entry is not there, return 0 and add plus. So this is the number our, so what, let me say, number is there, frequency what, we will use the same frequency map and then use the get or default. You must be knowing get default, what it does, it take the argument, and if there is no value for that key, it will return the 0. For now we have integer, so it will return 0. We can have any string or something, based on that we can assign the default value. So what we are saying that okay, get the default and then add the frequency to 1. So after the end of this one, here we have the map ready. So frequency map is ready. Now what we'll do is, once frequency map is ready, we need to insert, or in the heap we need to create the heap. Now for the heap, as we created another video also, we'll use the priority queue. Now here, as I said in the video, we need to maintain the both. We need to maintain the key as well as the value. That means the frequency as well as the number. Now we can maintain in the two way. We can either have the integer array, which first value will be like suppose frequency and second will be actual value. So that we can maintain it, or we can maintain the map entry also, because we will be iterating through the map entry. You see, we'll iterate through this map, and then we'll keep inserting in the priority queue. So better what we can do is, instead of defining the integer array, we can have the map dot entry. So why we are doing this one is, so we will not need to convert or take key value from the map and then create integer array, then again insert it, so that it will save our time. So just to save the time, I'm creating this priority queue with the map entry. Okay, so let's complete this priority queue, and this is done. So I'm saying this is maybe the minimum heap, or you can say At the end it will be returning top k numbers also, you can say it. So it can say top k numbers, anything is fine. Now what we'll do, we will insert in this heap. Okay, or you can say we will prepare the minimum heap. Okay, so for that one, we will iterate through this hash map as we did in the video part, explanation part. We'll iterate through the hash map and we'll keep inserting in this heap, minimum heap, or you can say top k numbers, whatever. Okay, let me put the top minimum heap only we used in the video. So this is the minimum heap for now, but it at the end it will give result of the top k numbers. So what we'll do it now, we'll iterate through this map. When we iterate through map, what it will give us the entry. So for each map entry, it is integer entry, and this what we have, number frequency. So we are iterating through the map, which will give us the entry. Did I make any mistake? Let's see. Oh, sorry. Yeah, I need to have the entry set, right? Because map entry set. Okay, I need to get the entry set, and then we can have the each entry from that set. Okay, fine. So now we are iterating through the number frequency on the map. Now we'll keep adding this entry, because see, in the priority queue we defined a minimum heap with the entry only, so we can just add the entry. Okay, now here we missed the one thing. When we adding the entry, it will keep adding it, but as we said, we are creating minimum heap. When we create minimum heap, there should be some sorting order, but in our heap priority queue or minimum heap, we haven't defined a sorting order. So let's define the sorting order here also. We need to tell them that, hey, based on what you will sort it. So we are saying that one, hey, if you get the two values, or here we are getting the entry, so let's say E1 and E2, two entries, you sort based on the value, because the value is the frequency, key is the number. So we are saying sort based on the value. That means E dot get value, E1 dot get value minus E2 dot get value. So we are saying this so that it will sort in the ascending order. Hope this is the clear. Okay, so now when we insert this one entry in the minimum heap, it will auto sort and it will create the minimum heap. So the smallest number will be on the top. Correct. Now we know that, hey, we want to make sure that in the minimum heap maximum k numbers will be there. So we just make sure that, hey, in this minimum heap, what is the size? So we are saying if the size greater than k, we want the k number. If it is reaching more than k number, then remove the top number root element. So minimum heap dot remove it. See, in the video we were saying that, hey, compare the top element and then remove it. But I think it's more simple here. We can make it. So what we are saying, we just insert it. We will insert it. It will auto sort the order, and the top number will always minimum. We can just remove it because we already added the sorted number. Now, once we come out of this for loop, we will have the minimum heap which will contain the top number. So at this moment, we have minimum heap ready. Now minimum heap, what is contained? It's contain the entry, map entry. Map entry is containing what? Two values. Key is the number and the value is the frequency. Now we are interested in the number, not frequency. So what we'll do is we again iterate through this minimum heap and we'll take the numbers. Correct. So let's iterate through this. What will iterate? We'll iterate through the minimum heap, right? So till what will iterate? Till this is not empty, because this is the queue will keep is not empty. Till it's not empty, we'll keep taking the new number. Sorry, the number from this one. Okay. And so if it minimum heap dot, if it is poll, it will give the map entry. And if I say get key, which will give us integer value. Correct. An that integer value is nothing but our number. So that means that number we can insert in this result dot add. Correct. So I can just copy this poll dot minimum and get key and inserting this one. Like that, I have the results ready. Let's go through the solution once again. What we did, we just created the map, hash map for the frequency. We defined the minimum heap and we defined the sorting order, so that should be in ascending sorted order. After that, we tried to map, we keep inserted entry in this minimum heap, and if the heap was going beyond the size, k size, we were removing the top number, which was the smallest number. Smallest number based on what? Based on the frequency, not the number. Just remember it. Okay. And then finally we have the minimum heap ready. We iterated through the minimum heap, and we just took the keys. So here just remember, we are taking the key. In the sorting order, we are using the value because we are interested in the frequency. While we sort it, when we return it, we are interested in the actual number. Okay. So this is clear. Then let's test it. So here we need what we need. We need the number. Correct. So let's give this number here. We want the list of number. Let's put some random number 1 3 6, sorry 6 7 3 4 9 0 8 2 6 7. Okay, and it will return this list, right? So let me copy paste here. Result, it will return this one, and I'm putting these numbers, and let me put the k is equal to 3. Okay, now we'll see what is the expected result here, because that is important for us. Here we have 1362, which is the more repeated. Just let me check it. One, yeah, I have not repeated number or what? Let me repeat few numbers. I think 7 I repeated, 2 I have repeated. Okay, let me repeat 7 one more time, or 2 more time. So 2 number repeated for the 3 time, then 7 number repeated for the 2 times. Oh, I have repeated one more number, 6 also, right? Okay. 6 number I repeated 2 times. 1 3 I have not repeated. 6 I have repeated. 7 repeated. 2 repeated. 5 not repeated. 0 not repeated. 2 repeated. I hope it is correct. Cool. So now let's print this result and see. System dot out dot print result. Okay, and let me run this program and see what happens. 7 6 and 2. Okay, so it's returned a 7 6 and 2, which was our expected result. 7 6 and 2. Yeah, order doesn't matter, as I said it. If it is asked explicitly to return in the this order also, you can just go here and just sort this list. Okay, let's change some value. We are repeating 7. Let me remove the 7. So 7 is one time now. Okay, 7 is one time now. So that means there are 1 is also there, 3 is also there, 0 is also there. It can return any number, mostly the last repeated number. 762. 7 is repeated one time. So 1 was repeated, 3 was repeated, 7 repeated. Let me remove the 7 also. Now let's see it. 1 6 2, 1 6 and 2. So 6 and 2 are all still there because they are repeated, and 1 it took the first number. It's depend on the frequency. I mean, it's random number it can be, or maybe it's lighting. We can check it. There can be guarantee also that which number it return it. But that's it on this video. I think time complexity we already covered. It was the big of n log k. So, so yeah, you can try it with different use cases or the test cases and see. You can try to implement also. We'll meet in the next video. Thank you for watching.